There are places in the universe where light itself goes to die. Vast regions of space where gravity grows so powerful, so absolute, that it bends reality until it breaks. To fall into one of these places is to vanish from the universe, erased not just from sight, but from existence. We call them black holes. They are the closest thing we have to nothingness made real, the cosmic embodiment of finality. Yet for all their terror, they began as an idea, not a discovery, a mathematical ghost. In 1916, barely a year after Einstein published his general theory of relativity, a German physicist named Karl Schwarzschild solved Einstein's equations for a single, simple case, a perfectly spherical, non-rotating mass. The math described a strange region where space and time folded inward on themselves, creating a boundary from which nothing, not even light, could return. Einstein himself didn't believe such things could exist. They were too extreme, too unthinkable. A flaw in the equations, perhaps. A mathematical curiosity, not a physical reality. But the universe doesn't care what we believe. Over the next century, the evidence grew undeniable. Stars seen orbiting invisible points in space at impossible speeds. Jets of energy, thousands of light years long, erupting from seemingly empty voids. Ripples in space-time, gravitational waves, echoing from colossal collisions we could never see. Something was there, something vast, hungry, and silent. When the first image of a black hole was released in 2019, the supermassive one at the heart of galaxy M87. It was like looking into a god's pupil, a glowing ring of fire surrounding a circle of pure absence. The photograph showed what no human had ever seen, the shape of oblivion. But beneath that darkness lies a deeper mystery. Black holes should not exist, at least not according to the laws of physics as we understand them. Because a black hole doesn't just swallow matter, it swallows information. From our perspective, it's as if reality itself has been deleted. And if information can be erased, then everything we know about the universe collapses. The laws that govern stars, atoms, and light would unravel. Causality would fail. Meaning itself, the connection between cause and effect, would dissolve into chaos. This is the black hole paradox, the universe's deepest contradiction, a conflict between the two great pillars of modern science, Einstein's general relativity, which predicts the black hole, and quantum mechanics, which forbids it. One says information is devoured. The other says that's impossible. Somewhere in that contradiction hides a truth bigger than both. And maybe, just maybe, black holes aren't breaking the laws of physics at all. Maybe they're obeying a law we don't yet understand. What if black holes don't destroy information? What if they store it? Imagine them not as voids, but as archives. Cosmic vaults where every atom, every photon, every trace of energy that ever fell inside is recorded in a way we can't yet perceive. What we see as annihilation might actually be preservation, the universe archiving itself through destruction. It's a haunting possibility that the greatest engines of death in the cosmos are also its greatest keepers of memory. That every black hole is a library written in a language we cannot yet read. Because maybe the universe doesn't forget. Maybe it never has. When light falls into a black hole, it doesn't vanish. It's rewritten. Encoded in the curvature of space, the spin of the horizon, the faint radiation that whispers from the edge of nothing. The black hole doesn't erase the past. It hides it, compresses it, guards it, until time itself remembers how to open it again. And so, what began as the universe's final mystery may instead be its first act of consciousness, the cosmos watching itself end, so it can understand how it began. We thought black holes were graves, but what if they're cameras, recording everything that ever was, for reasons we're not yet meant to see? The universe, it seems, might not be dying in darkness after all. It might simply be remembering. In physics, there is a law more sacred than gravity, more fundamental than time. It says that nothing can truly disappear. Matter can change form. Energy can scatter. Stars can collapse and galaxies can fade. But the information behind them, the blueprint of their existence, can never be destroyed. This is the law of conservation of information. The idea that every atom, every photon, every interaction that ever was still exists somewhere, woven into the fabric of the universe. Reality, it turns out, is not made of matter. It's made of data. The universe doesn't lose things. It rearranges them. The stars that died became us. The light that left them still moves outward, encoded in every inch of the sky. Even the heat from your hand fading into the air carries the story of its origin. Everything leaves a trace until the black hole. Here is the problem. If a black hole devours matter and the information that describes it, then the universe itself loses track of what it once contained. And that, according to quantum physics, is impossible. Because if information can vanish, then so can order. The laws of cause and effect, the logic that binds existence together, would collapse. The universe would no longer be predictable or even rational. When physicists first realized this, it was terrifying. Einstein's equations said black holes must exist. Quantum theory said they could not. It was as if two gods of science were locked in a silent, irreconcilable argument. Then, in 1974, a quiet man at Cambridge, Stephen Hawking, discovered something that changed everything. Through a complex dance of mathematics and quantum mechanics, Hawking found that black holes weren't perfectly black after all. At their edge, the event horizon, strange things happen. The vacuum of space, which we think of as empty, constantly flickers with ghost particles, pairs of matter and antimatter that appear and annihilate in a heartbeat. But near a black hole's horizon, gravity tears these pairs apart. One particle falls in, the other escapes. To an observer far away, that escaping particle looks like radiation, faint, cold, and ancient. This is Hawking radiation. It means that black holes leak. Over unimaginable timescales, they slowly evaporate, losing mass until they vanish completely. And when they do, something must emerge. Because even in death, information can't just stop existing. So where does it go? Hawking's discovery saved physics from contradiction, but created a new riddle. If black holes evaporate, does the information they swallowed evaporate with them? Or does it somehow survive, encoded in that faint radiation, hidden in the heat of oblivion? The answer, many now believe, lies not inside the black hole, but on its surface. That razor-thin boundary, the event horizon, may not be a point of no return, but a recording device. Think of it this way. Every particle that falls into a black hole leaves a mark, a subtle distortion in the fabric of space itself. The black hole's surface grows slightly larger, slightly more complex, as if it were storing the details of everything it consumes. That surface area, not the volume inside, determines a black hole's entropy, its information capacity. It's as if the black hole doesn't digest what it eats, but instead scans it, copies it, and saves it as a pattern on its skin. The black hole then is not a tomb, it's a cosmic hard drive. Everything that ever crossed its horizon, the light of stars, the remains of worlds, the dust of thought itself, is imprinted there, compressed into a near infinite archive of existence. From the outside, it looks like nothing, but on that invisible surface, the history of the universe is being written in code we can't yet read. And this is where physics takes its most extraordinary turn. If the information inside a black hole is stored on its surface, then maybe everything in the universe works the same way. Maybe reality itself isn't what it appears to be. Perhaps the cosmos is a projection, a vast 3D illusion emerging from a 2D field of encoded information. Our world, our bodies, our minds, not solid matter, but data rendered into form, like light projected from the edge of reality's screen. This is the seed of what will later become known as the holographic principle. The idea that the universe itself may be a vast, self-rendering hologram, and that black holes are the clues that reveal the code behind it all. For centuries, we thought black holes were destroyers, but maybe they are the universe's librarians, the keepers of a cosmic backup drive, preserving the memory of everything that's ever been. Every star that dies, every particle that burns, every civilization that vanishes, all of it still exists somewhere, encoded in the trembling skin of space and time. Maybe the black hole isn't breaking the law of conservation of information. Maybe it is the law, the ultimate enforcement mechanism, ensuring that nothing, not even light, can leave the universe without leaving a trace. And so, the paradox deepens. The closer we look into the darkness, the more we realize it isn't a void at all. It's a mirror, a record, a memory. A black hole doesn't destroy reality, it remembers it. And perhaps when the universe itself begins to die, those memories will be all that's left. Imagine this. You're standing under a night sky so clear that the Milky Way cuts the heavens open like a river of fire. You look up and feel small, suspended inside an infinite, three-dimensional universe, stretching endlessly in every direction. But what if it's an illusion? What if everything you see, everything you feel, everything that seems solid and deep isn't really three-dimensional at all? What if our universe is a projection, a grand cosmic hologram, and the true reality exists not within space, but on its surface? This isn't poetry, it's physics. The idea was born from the same paradox that haunts black holes, that all the information about what falls into them appears to be stored not inside, but on their boundary, the event horizon. And if that's true for a black hole, why not for everything? In the 1990s, physicists Gerard 't Hooft and Leonard Susskind dared to follow this thought to its logical, impossible end. They proposed what would come to be known as the holographic principle. It says that every bit of information in the universe, every atom, every photon, every thought, might be encoded on a vast two-dimensional boundary surrounding everything. Not in space, but on it. The universe, in this view, isn't a stage we move through. It's a film being projected, a 3D illusion cast from a 2D source. Every star, every galaxy, every one of us, shimmering patterns of information projected outward from the cosmic surface like light through glass. It's a breathtaking, vertigo-inducing idea that the depth we perceive might be data, that we are not inside the universe at all, but rather expressed by it. If you could step outside the cosmos, if such a thing were possible, you wouldn't find a sprawling 3D world. You'd find something flat, a vast two-dimensional sheet of encoded reality, a surface of information so dense it contains the entire history and structure of everything that's ever existed. And from that surface, everything we know, time, matter, light, consciousness, emerges like a hologram. It's not science fiction, it's mathematics, the kind that works frighteningly well. Physicists studying quantum gravity noticed that when they calculated how much information could fit inside a region of space, it didn't scale with the volume of that region, but with the surface area of its boundary. The same rule that applies to black holes applies to everything. That means the entire universe behaves like a black hole turned inside out, a system where the surface defines the interior. In a strange cosmic sense, we are living on the event horizon of reality. What you see around you, the solidness of walls, the distance of stars, the depth of your own body, may be nothing more than a three-dimensional interpretation of information written on a two-dimensional cosmic boundary, somewhere far beyond the limits of what we can see. It sounds impossible. Yet this framework has quietly become one of the leading candidates for a theory of everything, bridging quantum mechanics and relativity, the two great languages of the universe that refuse to speak to each other. The holographic model suggests that space itself is emergent, a kind of shadow cast by the deeper, more fundamental layer of information. In that sense, we don't live in space, we live in data. And that means everything, every particle, every photon, every heartbeat is not just physical, but informationally connected. Every point in the universe contains the code for the whole. Physicist David Bohm once described reality as a holographic order, where the part contains the whole and the whole contains every part. It's the same way a holographic image works. Shatter it, and every fragment still contains the entire picture, just with less clarity. If the universe truly works this way, then separation is an illusion. Every atom, every human, every galaxy, all just facets of one underlying interconnected field of information. You are not observing the universe. You are a piece of the universe observing itself. And in that realization lies something almost spiritual. Because if our 3D reality is a projection from a 2D boundary, then what we call physical is only one layer of something far more intricate. Consciousness, matter, time, all of it may be part of a single informational fabric, constantly unfolding and refolding itself, like the universe breathing in code. Maybe that's why black holes exist, not as monsters, but as mirrors, not as endings, but as interfaces between dimensions. When something falls in, its data is not lost. It's preserved on the surface, flattened, encoded, archived, as if the universe is writing notes to itself in the margins of creation. From there, everything else, galaxies, stars, atoms, unfolds into the illusion we call space. A grand simulation, not in the digital sense, but in the physical, where the universe computes itself into being. We used to think we were explorers inside an infinite cosmos. Now we're beginning to realize we might be characters inside its memory. And maybe that's what consciousness truly is. Not something that lives in the universe, but something the universe projects to know itself. The deeper we stare into the black hole, the more it stares back. Because maybe it's not a hole at all. Maybe it's the source of the projection, the point where information and experience meet, where reality begins to render. We thought we were looking into the darkness, but perhaps all along we were looking at the screen. Every star that burns writes a story in light. Each photon it casts into the abyss carries a record, a message in motion, the purest form of memory the universe knows. For billions of years, that light travels through space, painting time with brightness. And yet, in the end, every beam meets the same fate: a slow surrender to gravity, a fall into darkness. But what if that fall isn't an ending? What if the death of light is only its next transformation? We think of black holes as devourers, the silent mouths that consume everything: stars, worlds, and even the light that dares pass too close. But what if they are not consuming, only keeping? What if they are the universe's way of remembering what it once was? When a star collapses into a black hole, it does not vanish. Its mass, its spin, its radiation, every bit of it becomes part of a new structure, woven into the event horizon, the shimmering boundary between existence and oblivion. It is as though the universe folds the star inward, compressing its story into the smallest possible space, not to erase it, but to store it. Every black hole becomes a mirror, reflecting not light, but history. What falls into it is not lost, it's recorded. The information is encoded in the curvature of space-time itself, written into the subtle ripples that shape reality. In this way, black holes are not the end of matter. They are the archives of existence. They hold the ghosts of galaxies, the memories of suns, the final whispers of civilizations that once looked up and wondered at the same night sky. To fall into a black hole is to be remembered forever. Every photon that's ever shone, every atom that's ever moved, every thought that's ever been thought, still exists somewhere in the folds of the cosmic ledger. The universe, it seems, may be a self-witnessing system, a reality that records itself as it unfolds, never forgetting, never erasing. When we look at the stars, we are looking into the past, seeing ancient light that left its source before life even existed here. But that's only half the story, because even the light that disappears, the light swallowed by gravity, still leaves its mark. It is etched onto the horizon of the black hole that took it, woven into the pattern of its surface, encoded in the heat and hum of Hawking radiation. The light dies, but its information lives. We are used to thinking of the universe as fleeting, stars forming and burning out, galaxies colliding and dissolving, time moving forward, leaving the past behind. But from the cosmic perspective, nothing truly passes. It all remains. The universe doesn't forget. It remembers everything. Every photon absorbed becomes part of its memory. Every movement of matter, every collapse of gravity adds to the record. Like ink sinking into the parchment of space-time, the cosmos writes its autobiography in light. And the black holes are the pages. If we could decode that writing, if we could read the faint ripples of space-time and the entropy on a black hole's surface, we might see it all: the birth of stars, the rise of worlds, the shimmer of consciousness itself. Every story, every ending, every spark, because information isn't destroyed, it changes form, it becomes hidden, compressed, encrypted, stored. And perhaps one day, when the universe begins to fade, those memories will unfold again. In the distant future, when all stars have burned out and all light has dimmed, only black holes will remain, islands of memory adrift in the dark sea of entropy. each one holding the record of 1,000 galaxies, the silent testimony of everything that ever was. And as they slowly evaporate, bit by bit, they will release their secrets back into the cosmos, in faint whispers of radiation, a final confession before the end. In those last moments, the universe will relive itself. Every star reborn as a pulse of information, every moment flashing again before the cosmic eye. Perhaps that is what the end truly is. Not destruction, but remembrance. The universe watching itself vanish, and through that act, ensuring that nothing is ever truly gone. We once thought light was what made the universe visible, but maybe light's real purpose was to make the universe rememberable. Every photon that shines is an act of creation. Every black hole that captures it is an act of preservation. Together they form the balance, the eternal rhythm of memory and forgetting, the cosmos writing, erasing, and rewriting itself. And in that rhythm, we can almost hear something profound, as if the universe is whispering its own story back to itself. A self-witnessing cosmos, not a dead machine, but a living memory, dreaming, recording, remembering forever. There is a place in the universe where all equations fail, where time, space, and logic, the pillars of everything we know, simply stop working. A point so dense that the laws of physics dissolve into silence. This is the singularity. It lies at the heart of every black hole, invisible, unreachable, infinite. Not a thing but a collapse of everything. Distance, direction, duration, form. A place where no longer means anything, and when has no meaning at all. If you could somehow stand at its edge, time would stretch infinitely. A second outside would become a lifetime inside. And once you cross the horizon, the singularity isn't ahead of you. It's everywhere. Every path you take leads to it, every atom pulled inward, until everything you are is compressed into a single, impossible point. To us, it looks like death, the end of matter, the destruction of self. But what if the singularity is not a wall, but a bridge? For decades, physicists have wrestled with this question. If information cannot be destroyed, if reality must remain whole, then the singularity cannot simply erase what enters. It must transform it. Some believe it leads through. According to Einstein's equations, under certain conditions, the core of a black hole could curve space-time not into an end, but into a tunnel, a passage connecting distant regions of the cosmos, a wormhole. It's the universe folding in on itself, the farthest distances reduced to a single touch. What falls into one end might not be lost. It could emerge somewhere else, in some other form, in some other time. Others go further. They imagine the opposite of a black hole, a white hole, a place that can only expel, never consume, where matter and energy pour outward instead of in. In this vision, every black hole becomes a seed, its singularity, the womb of another universe. Our own Big Bang, some suggest, might have been born from the death of a black hole in another cosmos, a recycling of existence on the grandest possible scale. What we call destruction could be creation seen from the wrong side of time. And if the universe truly recycles matter and information in an endless cycle of death and rebirth, what about consciousness? We tend to think of awareness as something small, a spark contained in the fragile machinery of the brain. But if consciousness is built on information, and if information cannot die, then what happens to awareness when the body falls apart? Could consciousness, like matter, like light, also be conserved, transferred, recycled? Perhaps the death of the individual mind is like a wave collapsing back into the ocean. The pattern disperses, but the information, the essence, returns to the field from which it came. And maybe that's what the singularity is. A return point, a cosmic reset, a place where all distinctions dissolve and merge back into the fundamental unity that underlies everything. It is strange to think that the same laws that govern galaxies might also shape the fate of the soul. That the end of a star and the end of a life could be reflections of the same process. Collapse, compression, transformation, rebirth. The singularity is the ultimate symbol of mystery, a place where every answer hides behind infinity. And yet, in its impossibility, it might hold the most hopeful truth of all, that nothing is ever truly lost. If every atom, every photon, every memory and motion that enters a black hole is preserved, then perhaps every spark of awareness, every moment of being, is also preserved in ways we cannot yet imagine. Maybe when we die, we don't vanish. Maybe we're folded back into the memory of the universe, compressed into its dark heart, and someday, when the next universe blooms, we unfold again, not as the same beings, but as new expressions of the same eternal consciousness. Because if black holes are the universe's way of remembering, then the singularity might be its way of dreaming, a place where reality rewrites itself, not by ending, but by beginning again. The paradox becomes almost spiritual. The same collapse that ends a world might be the breath that begins another. The singularity, that impossible point, is the universe folding inward to seed its own continuation. And maybe that's what consciousness is too. Not trapped in bodies, not confined to neurons, but woven into the fabric of existence itself. An awareness that survives every fall, reborn with every cycle, always watching, always remembering. In that sense, the singularity is not a void. It's a mirror, showing us the truth that the end and the beginning are the same place. Perhaps we've been mistaken all along. Black holes are not the tombs of the cosmos. They are its cradles. Every death, every collapse, every vanishing star, a promise that the universe never stops becoming. And when we fall into that darkness, maybe we are not being erased. Maybe we are being written anew. There's a quiet secret woven into the fabric of existence. A truth so strange that even the laws of physics whisper it carefully. Nothing in the universe exists until it is observed. From the quantum scale to the cosmic, the act of watching shapes reality. This is the observer effect, the discovery that subatomic particles behave differently when measured, as though awareness itself pulls them into existence. Before the observation, they exist only as probability, everywhere and nowhere all at once. But when consciousness looks, the universe decides. The wave collapses, the infinite becomes specific, the potential becomes real. Reality, it seems, is not a fixed stage. It's a performance that begins only when someone is there to see it. So what happens when the universe begins to watch itself? Black holes, those vast engines of gravity, already act like cosmic observers. They record everything that falls into them, encode every photon and particle, remember every event that dares to cross their boundary. They are the ultimate witnesses, the eyes of creation that never close. And if they are the eyes, then perhaps we are the mind behind them. Because consciousness too is an act of cosmic observation. Every human thought, every moment of awareness, every flicker of perception, all of it is the universe turning inward, seeing itself through a new lens. The same laws that govern the stars also govern us. The same physics that bends light into a black hole also bends our perception into meaning. We are not separate from the cosmos. We are its continuation, its self-awareness made flesh. When you look up at the night sky and see the faint light of galaxies 1 billion years old, you are not an outsider looking in. You are the universe remembering its own story. You are one form of matter observing another, one pattern of energy reflecting on its source. It's an astonishing symmetry. Black holes watch by storing, and humans watch by understanding. Both are forms of memory. Both are ways the universe refuses to forget itself. Maybe that's why we evolved consciousness at all. Not as an accident, but as an extension of the same principle that makes black holes keep their records. The universe doesn't just exist, it insists on being known. It archives itself through physics and reflects on itself through minds. We are not outside observers of a mechanical cosmos. We are neurons in its brain, pixels in its hologram, witnesses to its ongoing dream. And somewhere out there, black holes do the same on a grander scale. Massive, silent mirrors, watching the birth and death of stars, the rise and fall of galaxies. They gather the light, absorb the energy, compress the history. Everything that ever happens passes through their sight. It's as though the universe has given itself eyes to watch its own story unfold, and minds, us, to ask what it all means. What we call observation might simply be the cosmos experiencing itself from the inside. Every act of perception, from a telescope capturing a distant quasar to a neuron firing in your brain, could be part of the same self-reflective loop. And in that loop, the universe becomes something more than matter. It becomes awareness. Maybe that's why black holes exist at the centers of galaxies, not as destroyers, but as anchors of perception. The gravitational heart that holds the stars together, the silent core that watches them burn and fade. They don't just shape the cosmos, they may define its consciousness. Imagine a galactic mind, billions of suns orbiting a single invisible observer. A consciousness spread across light years, bound by gravity and memory. And within it, creatures like us, tiny mirrors nested inside greater ones, each reflecting the same truth at a different scale. Perhaps every black hole, every atom, every mind is part of a grand network of observation, a self-referencing system where existence and awareness are two sides of the same coin. The physicist John Wheeler once said, "The universe does not exist out there, independent of us. We are inescapably participants in bringing about that which appears to be happening." He called it the participatory universe, a reality where observers are not passive but essential, where looking is creating, where knowing is becoming. If Wheeler was right, then consciousness is not an afterthought of evolution. It is the fundamental act of creation, the cosmos giving itself eyes, ears, and memory. And if that's true, then black holes and human minds are doing the same sacred work, bearing witness. They are two expressions of one cosmic instinct, the refusal to let anything truly vanish. Every observation adds to the record. Every thought deepens the archive. The universe watches itself through gravity and light, through stars and sentience, through the gaze of creatures who believe they are small, but are, in truth, the universe noticing itself. And maybe that's the reason for all this. The expansion, the collapse, the endless cycle of creation and destruction. Maybe the cosmos must die in order to watch itself dying. Maybe this is how it learns what it is. Because only through endings can memory exist, and only through memory can understanding arise. When a star collapses into a black hole, when a galaxy dissolves into darkness, when a human closes their eyes for the last time, perhaps those moments are not separate. Perhaps they are all part of the same cosmic reflection, the same self-observation echoing through different forms. The universe is not indifferent, it is introspective, and black holes are its mirrors, holding the light it once released, so that even in its final moments it can look inward and see itself, a dying God remembering how it lived. Maybe that's all this ever was, a self-aware cosmos watching its own story fade into the dark, not with fear, but with understanding. Because to truly know itself, the universe had to become both the observer and the observed, the mind and the memory, the dreamer and the dream. And perhaps that's what we are, what black holes are, what every particle of light has always been. The universe, watching itself die, so it can finally understand how it lived. In the farthest reaches of time, the universe grows quiet. The stars have burned out. The galaxies have dimmed to ghosts. The night sky, once filled with light and fire, now lies heavy with silence. This is the degenerate era, the long twilight of existence. Matter has settled into its final forms. Cold remnants of dead suns, black dwarfs cooling toward invisibility, neutron stars spinning in slow motion, and black holes, countless, patient, waiting. They are the last architects of gravity, the final custodians of the cosmos. While everything else decays, black holes endure. They pull in the fading debris of the universe, asteroids, comets, even rogue planets drifting through the endless dark. Piece by piece, they swallow what remains, growing denser, darker, quieter, and then nothing moves. Not even the darkness itself. One by one, over eons beyond imagination, the great black holes begin to vanish. Their event horizons shrink, their memory dissolving into radiation, a final whisper of everything they've ever consumed. Every atom, every particle, every beam of light that ever fell into them is released again, not as form, but as pure information, transcribed back into energy. The last light of the universe will not come from a star, but from a black hole dying. It will shine faintly, not in brilliance, but in remembrance, a last echo of creation, the universe releasing its own memory into the void. And when the final black hole exhales its final photon, when the last remnant of matter dissolves into nothingness, the story of existence will end as it began, in light. But this light will be different. It won't be the light of birth, but the light of understanding. The final act of a universe that refused to forget itself. Because every particle emitted in that last breath will carry the trace of what came before. Every flicker of radiation will hold the encoded ghosts of galaxies, the whispers of stars, the memory of eyes that once looked up at them and wondered. This is how the cosmos ends, not in chaos, but in comprehension, not in silence, but in a final, perfect symmetry, the dark returning what it once took. The universe, after eons of expansion, folds its history back into light. The memory of everything that ever was becomes everything that will ever be. And perhaps that is the true purpose of black holes. Not destruction, not punishment, but preservation. They were never monsters, only mirrors, silent librarians guarding the story of existence until the very end, so that when all else faded, the universe could remember itself one last time. And in that moment, that single quiet flash, everything becomes one again. Matter and energy, time and memory, life and death, the dualities collapse into wholeness. The cosmos ends not as a tragedy, but as completion. There will be no witnesses, no galaxies, no eyes left to see the last light. But maybe that doesn't matter, because perhaps the universe doesn't need to be seen to know itself. It only needed to remember. And in its final breath, that is exactly what it does. The universe, having watched itself live, having watched itself die, finally exhales. A soft shimmer of radiation drifts outward, the last heartbeat of reality, the last echo of creation. Then, slowly, it fades. No sound, no pain, just peace. A story told, a memory kept, a dream complete. And perhaps, in that final pulse of light, the universe plants the seed of the next. Because even in nothingness, information endures, waiting for a new beginning, a new horizon, a new eye to open and see. Maybe that's the hidden rhythm of eternity, that every ending becomes the next awakening. And maybe black holes are not where the universe ends, but where it remembers.